Have you ever wondered, why does the sun disappear in the middle of the day? Or why does the moon turn blood red at night? Welcome to the enigmatic world of eclipses, where the ordinary becomes extraordinary, and the familiar sky transforms into a stage for celestial spectacles. Let's start with the basics. What is an eclipse? Well, in its simplest form, an eclipse is an astronomical event that occurs when one celestial body obscures the light from another. These captivating phenomena come in two main types: solar and lunar eclipses. Solar eclipses, the daytime divas of the sky, are a sight to behold. They occur when the moon, in its orbit around the Earth, passes directly between the sun and us, casting a shadow on parts of the Earth. For a brief moment, the sun, the star of our solar system, seemingly vanishes, leaving us in an eerie daytime darkness. On the flip side, we have lunar eclipses, the nighttime marvels. These occur when the Earth finds itself between the sun and the moon, causing the Earth's shadow to fall on the moon. The result? A striking spectacle as the moon, our constant companion in the night sky, takes on a deep red hue, often referred to as a blood moon. Both these events, while vastly different, share a common thread. They serve as a reminder of the intricate dance of celestial bodies, a ballet choreographed by the laws of physics and gravity. But why do these phenomena occur? What are the mechanics behind these celestial spectacles? Is there a pattern or a cycle to when they happen? And what can they tell us about our place in the universe? These are the questions that have intrigued astronomers and stargazers for centuries, leading to a wealth of scientific discoveries and advancements. Intriguing, isn't it? Let's delve deeper into the science behind these celestial spectacles. Imagine you are standing under the open sky on a sunny day, and suddenly, daylight turns into twilight. What just happened? Well, you've just experienced a solar eclipse, a celestial ballet where the moon pirouettes between the Earth and the sun, casting a shadow that brings an unexpected dusk upon us. But how does this cosmic dance come to be? It all begins with alignment. As the moon orbits the Earth, there are moments when it comes to stand directly between us and the sun. This alignment, known as a syzygy, is the first step in the formation of a solar eclipse. Now, not all solar eclipses are created equal. There are three main types: total, partial, and annular. In a total solar eclipse, the moon completely covers the sun, leaving only a radiant halo or corona visible. This happens when the moon is close enough to us to entirely block out the sun. But when the moon is a little further away, it appears smaller in our sky and can't entirely cover the sun. This results in an annular eclipse, or a ring of fire eclipse, where a bright ring of sunlight remains visible around the moon. And then there's the partial solar eclipse, which is exactly what it sounds like. The moon only partially obscures the sun, making it seem as if a celestial being has taken a bite out of our star. But perhaps one of the most intriguing aspects of a solar eclipse is the path of totality. This is the narrow strip of land where observers can witness a total solar eclipse in all its glory. Outside this path, only a partial eclipse can be seen. Total solar eclipses are a rare spectacle. They occur somewhere on Earth about every 18 months, but the chances of them occurring at any specific location are once every 375 years. That's longer than most human lifetimes. So that's how our mighty sun can seemingly disappear in broad daylight. Quite fascinating, don't you think? Now let's switch our gaze to the night sky. Ever notice the moon taking on an eerie red hue? This captivating spectacle is known as a lunar eclipse, a celestial event that has fascinated humans for millennia. But what exactly is happening during a lunar eclipse? Well, it all begins with the perfect alignment of the sun, Earth, and moon. When the Earth moves between the sun and the moon, it casts a shadow on the moon. This shadow has two parts: the penumbra, a faint outer shadow, and the umbra, a dark inner shadow. As the moon passes through these shadows, we witness a lunar eclipse. Now, you might be wondering, why does the moon turn red during a total lunar eclipse? It's a phenomenon known as Rayleigh scattering. When sunlight passes through the Earth's atmosphere, it scatters short wavelength light, like blue and violet light, to the sides. This leaves behind the longer wavelength light, the red and orange light, which then reaches and illuminates the moon. A lunar eclipse typically progresses through several stages. First, we have the penumbral eclipse, when the moon begins to dip into the Earth's faint outer shadow. Next is the partial eclipse, where the moon starts to enter the Earth's dark inner shadow. Finally, we reach the total eclipse, when the moon is fully ensconced in the Earth's umbra, bathing in a ghostly red glow. The best part? You can safely watch a lunar eclipse with your naked eye. No special glasses or equipment needed, just a clear sky and a sense of wonder. So next time you see the moon blushing in the night sky, remember, it's not just a beautiful sight. It's a celestial ballet of shadows and light, a testament to the grandeur of our universe and the laws that govern it. And that's why our serene moon can turn into a blood moon. Amazing, isn't it? So why do we experience these breathtaking moments of celestial shadow play? Let's take a moment to recap the marvels we've delved into. Eclipses, in essence, are celestial events where either the moon or the Earth momentarily blocks the sun's light. Solar eclipses occur when the moon slips between the Earth and the sun. This alignment casts a shadow on our planet, momentarily plunging certain areas into darkness. There are 3 types of solar eclipses: total, partial, and annular, each providing a unique spectacle for skywatchers. On the flip side, we have lunar eclipses. They transpire when the Earth glides between the sun and the moon, casting its shadow onto the moon. We've learned that lunar eclipses also come in 3 variants: total, partial, and penumbral. Each unfolds a different, mesmerizing display in our night sky. But what makes these events truly fascinating is their rarity. The cosmic ballet of the sun, the Earth, and the moon must align perfectly for an eclipse to occur, making these celestial phenomena cherished moments for astronomers and enthusiasts alike. Moreover, eclipses have played a crucial role in our understanding of the solar system. From validating Einstein's theory of relativity to helping us measure the moon's distance, these shadowy spectacles have been instrumental in advancing our knowledge of the cosmos. Yet it's not just about the science. Eclipses also invite us to reflect on our existence within this vast universe. As we watch the moon or Earth cast their shadows, we're reminded of the cosmic dance we're all part of. They serve as humbling reminders of our smallness against the grand backdrop of the universe. And there you have it, the science behind the dramatic dance of shadows in our sky. Remember, each eclipse is a reminder of our place in the vast cosmos. So next time you witness one, pause and marvel at the grandeur of the universe.